Hey everyone, welcome to the second video this week, and actually the last one I'm going to post for this week, just because I don't want to overwhelm you folks, especially with the whole coming back to school for next week. If some of you are planning to do that, so please take it easy this week. I'm just going to post these two videos, and I'll update some marks for the most recent folks who have handed stuff in. So this is the last thing we're going to cover. We're going to go straight to an example. It's very similar to what we've been talking about in the past with the whole ratios and proportions, and talking about similar figures. And so we know that a similar figure, even though they might not be the same size, similar figures, essentially, similar figures share the same angles, and they look pretty much as the exact same shape. They're just either they're scaled down to something smaller or they're scaled up to something larger. And what we can do, if we don't know the side lengths of the scaled down or scaled up version, but we know the side lengths of all of the original shape, and then we know at least one side length of the scaled down or scaled up shape, we can solve for all the rest of the sides because we can figure out what the shape is scaled down by or scaled up by. So I'm going to explain this more with this example here. We're just going to do this one because it's basically for all future homework that I would assign with determining sides. It's the same process, like nothing changes. So we're looking at an example here where Tara has made a diagram of her bedroom. And on the diagram, the walls have the following lengths. So we have A, B, C, D, E, and F, and each of those has their own respective lengths in inches, right? And this is asking the longest wall that Tara is going to actually have is 12.75 feet. So it's a lot bigger. And the question that we're asking ourselves is, well, what are the actual lengths of the other 5 walls? So remember, this down here, this is just a scaled down version or a diagram of what she wants her room to look like, okay? And we know at least one size of what it will actually look like, okay? So what I'm going to do, I'm going to label each of these sides here. We got A, B, C. Oh, actually, sorry, they're all already labeled. I'm going crazy. I am going crazy, Mr. Carroll's going crazy. Okay, they're already labeled, just super nice. So what we're going to do, I'm going to set up a exact replica of this, okay? Just to stay consistent with what I'm trying to drive home here. So it probably looks something like that. Wow, that was actually really nice. And so this is we're going to call this the scaled up version. Scaled up, or the bigger. Okay, the bigger version. And on this bigger version, Tara knows that the longest wall is actually 12.75 feet. So it's not 8.5, which is what she did in her scale down one. It's actually 12.75. And we want to figure out, well, what are the lengths of the other 5 walls? How can we figure out? And let's label these. So we have A, B, C, D, E, F. Let's call this G, H, I, J, and K. So we need to figure out what these lengths are, okay? And we can figure that out because we can figure out what the relationship between 8.5 and 12.75 is. So let's set up that ratio right now. So we're going to set up our initial ratio of 8.5 to 12.5. Okay. And since we know this is a similar figure, we know that this ratio has to be equal. It has to be equal to another ratio here. So what can we make another ratio? Well, let's figure out the length of G here. And so we know that the length of G is related to the length of B, right? They're the same side. So it has to be related to 6 in some way. Well, we know how it's related to 6 because we know what the ratio of one of the walls is. So what we're going to do, we're going to write down the original ratio. So you see in this that we're keeping all our original numbers in a scaled down version on the numerator, and then we're putting all our unknowns down here in the denominator. And so we don't know what this side length is, right? So we got 6 over G. And now we just need to solve for G. So solve G. So how can we do that? Well, we could do cross multiplication first with this 12.5. So let's do that. And we get 8.5 over 1. Sorry, let's just leave this as 8.5 equals 6 times 12.5 all over G. Well, we're almost done, but G is down here. We want to get G on its own. So what if we cross multiplied it with the 8.5 so that we switch spots here? Right? If we did that. So now we're actually G equals 6 times 12.5 all over 8.5. That way G equals, let's figure out what that is. 6 times 12.5 divided by 8.5, we get about 8.82. 8.82 feet. Okay. Let's figure out h now. So solve h. So same thing. We're going to use the ratio that we know. We know 8.5 over 12.5. We're always going to use this one equals. What was the scaled down version of h? So h is 6.5 over h. Let's do our cross multiplication. What are we going to get? Well, we get 8.5 equals 6.5 times 12.5 over h. We can do cross multiplication again, and we get h equals 6.5 times 12.5 over 8.5. H equals, figure out what that is, 6.5 times 12.5 divided by 8.5. We get 9.56 feet for h. Okay, so you see the kind of general pattern that this is following. We're taking, oops, did I do that right? Yeah. Sorry. Just double checking here. We're dividing by the same amount here for this ratio, and we're essentially just replacing this number here, this first number here, with whatever the side length was of the scaled down version over here. So to find c, let's just follow that. So we don't want to do as much steps. So we're going to have c equals, what did c equal up here? C equaled 6.5 times what? Six and a half. Oops, sorry, going crazy. Times 12.5. All over 8.5. C equals, and we can figure this out, 6.5 times 12.5 divided by 8.5. We get 9.5. How does that work? Those can't be the same, are they? 6 and 6.5. Oh, right, I did the same one. I did the same one here. This one should actually appear. This one should be, oh no, I'm going insane. We already solved for that one. I'm going crazy. Sorry, folks. So instead of solving for C, we want to solve for D. And for D, what do we have? Not 6.5 here. That's why I was going crazy. 2.8. Sorry. 2.8. So we do D, and what do we get for this one? Okay, we're back on track. 2.8 times 12.5 divided by 8.5. There we go. We get 4.12. Good. Okay. Solve. Sorry, it's not even D either. It is, that would be I. H. I. What are we up to next? J. We're up to J. Solve J. So what are we going to get for J? Well, J is on its original. It was 2 inches that she wrote. So we'll just plug that in. We got 2 times 12.5 over 8.5. What do we get? It's going to be 25 divided by 8.5. We get 2.94. And then we could solve K. And we said that K is going to be equal to what was its original length. So K here, its original length was 3.4 inches. 3.4 times 12.5 over 8.5. And we get K is equal to 5. And that's the gist of it, folks. So all the questions I'm going to give you are going to be very, very similar to this in terms of figuring out what the side lengths are. So that is it. That's all I'm going to give you for this week. If you have any questions, please feel free to shoot me an email and we can discuss how to help you out. Other than that, I hope to see some of your smiling faces next week. And that is it. All right. Take care, everyone. Bye-bye.